Hi everyone. So we are resuming the session that we started yesterday. Today's objective is to find squares and cubes. I mean, this is the first objective for today. How to quickly calculate squares and cubes of numbers. It's not very important, but sometimes it is useful in places where you need the options are a little closer, and estimating options are not working to your advantage. In those areas, sometimes if you know these techniques are very helpful. So without further ado, let's start with it. First, I'll discuss the squaring technique. So I don't believe in by hearting techniques, so I'll just start with something like this. So let us say we have a number like this, 50m plus d whole square. If I square this, I get something like 2500 m square plus 100 md plus d square, right? And if I take the 50m common from these two terms, so what I have effectively is 50m plus 2d left up and plus the d square. So what I have is 50m something into 50m plus 2d is here. So I'll just write this as 50m plus d plus d and the plus d square. This is basically the shortcut. So if I have the number 50m plus d, so suppose, let me take an example. Suppose I have a number like 67. Uh, 50m means a multiple of 50. So which is the closest multiple of 50 to 67? So that is 50, right? So 67 is nothing but 50 plus 17. So just take a note of this d. What is this d? This is 17. So what we need to do is, if this 50m plus d is the number itself, so what first step, add the d, that is the deviation basically. So add the deviation of the number to the number itself. So 67 plus 17, so that is 84. And then the next step is, so multiply this multiple of 50 from wherever you took the deviation from. So you took, in this case, the deviation from 50. So you need to multiply 50, right? And 50 multiplied is basically 100 by 2, isn't it? So whenever you're trying to solve this mentally, you must be doing something like this. So in this case, what you're doing is you are adding the deviation to it, dividing by 2 and just putting two zeros behind it. So effectively what you have is 4200, and then the last step, simply add the 17 square. So what you have is 4489, 17 square being 289. So now the only thing that you have to remember, I think we already mentioned this in our session plan, you must be remembering squares from 1 to 25, because this d can go up to 25 square, because we are taking a deviation from multiples of 50. So if it is from 50 or from 100, the average is 75, right? So in that case, the maximum deviation can go up to 24, 25. For 5 and numbers, for numbers ending with 5, this is a very short process, which I'm going to come to just after this. But just try to remember these squares up to 25, right? Next thing, let us take another number to explain this again. So let's say 87, 87 square. Now 87 square, the closest multiple of 50 is 100 in this case. So this is 100 minus 13, right? So we have to just take a note of this minus 13. So the first step, the number, the deviation adjusted. So 87 minus 13. The sign is important, all right? Whenever you have, so in the previous case we had a plus 17 deviation. So we added 17. In this case we have a minus 13 deviation. So we are subtracting 13. So 87 minus 13, which is 74. And in this case we have to just multiply 100, which is nothing but adding two zeros behind it. And now minus 13 square or plus 13 square doesn't make any difference. It is always going to be plus, right? So what we have is 7569. So that is the idea of squaring a number, the fastest way of squaring a number, provided you remember squares from 1 to 25. As I said, this can be applied to any number, any number which has a multiple of 50. So even, I mean, scary numbers like let's say 983 square, if you have number like this, so that is having a minus 17 from 1000, right? So what you have to do is 983 minus 17, so that is 966, and then as we are taking it from 1000, so 3 zeros, and then the 17 square, so that is 289. So effectively what we have is 966 289. Trust me, if you practice this a bit, hardly take 5 to 10 seconds. Depends on which number you have to multiply. So if you need to multiply a 700 or something, it would take a bit of time. Multiplying other numbers like 400, 300, these might be a little easier for you. So try to understand and apply those multiplication techniques also. So whatever you're trying to multiply, that is an important thing. Wherever you're taking a division from, but I don't think it would be a little too calculative in nature, but definitely this is going to save some time. So the next part that we're going to discuss is the numbers ending with 5. So let's say we have 65 square. Okay, so simple process. What you need to do is just 5 square is 25. So just write 25 at the end, and then apart from the 5 in this number, you have 6 here, right? So what you need to do is you need to multiply 6 to the next number, which is 7. So 6 into 7, so that is nothing but 42. So the result is 4225. So that is a square of 65 out here. The logic is again as simple as that. You can just square this up and check the result yourself. You'll understand what is happening here. So 65 square is 4225. But if you have stuff like 135 square or something like that, again you have this 5 square, so again that is 25, that is fine. But then 13 into 14, I mean, if you're not good with tables, that might be a bit of problem, right? But then if you observe something, 13 into 14 is nothing but 13 into 13 plus 1, and which is effectively 13 square plus 13. So instead of doing 13 into 14, you can also do 13 square plus 13. That might be an alternative process. So 13 square is 169 plus 13 is 182, so that might be a little faster. So sometimes this also works, so just keep this small little variation in mind. So that is all about squaring. We'll quickly move to cubes now. I'll just take these things off. And just give me 1 minute. Okay, I think that is enough. Yeah, so in terms of cubes, there are a lot of processes, but the idea is simple. I mean, see, end of the day, if you have to calculate a cube, I think for the scope of CAT or other such exams, 2-digit cubes are more than enough. So I don't think 3-digit cube would be too much of a requirement. The only thing that you have to understand is a plus b whole cube, right? I mean, I hope everybody is aware of a plus b whole cube. So I'm not going into detail of that. So we're going to use this process. You're going to use this process in, I'll just break it down into few things here. One would be either x1 or 1x, numbers like this. And then I would take up something like xx. So these numbers, and the rest, I don't feel that there is direct shortcut. I mean, it's just applying of that a plus b whole cube only. So if you want, you can definitely get into it. Otherwise, I mean, it's fine. I mean, just try to test it with options and all. But I'll discuss the process for that also, for the other kinds also. So if I take x1 whole cube, so something like, let's take an example. Let's say 21 cube, right? Let's start with a simple one. So 21 cube. So what we're going to do is first step, I start with the right hand side. So I'll go with 1, then I'll go 2. So this 2 here. Then I'll go 2 square, and I'll go 2 cube. Alright, so this is as simple as that. 1, 2, 4, and 8, right? Just multiply the middle two values. So multiply 4 and 2 by 3. So multiply 4 with 3 and 2 with 3. So what you get is 12 here, and you get a 6 here, right? Now we are going to write the number. So now if you check, I'll just put the numbers down. So 1 comes down as 1. The 6 comes down as 6. Now the 12, both the digits cannot come down. So the 2 has to come down and the 1 will be carried over, right? So the 1 gets carried over and we have a result as 9261. So that is a cube of 21. So I'll just elaborate this with another example. So 31 cube, let's say. So quickly doing this, 1, 3, 9, 27. Triple these. So I'm just tripling, I'm not writing the into 3. So you have 9 and 27 again. Now just get the result. 1, 3 plus, then what you have is, instead of 3, you just take this 9. So just forget about these values, alright? Just 1 here, you get this 9 down, you get this 7 down, and you have this 29. So basically what you have is 29791. I hope that is understood. 7 down and the 2 carried. So this would be directly 29. So that is for 21 cube or 31 cube. So numbers are like the form x1. The other one is also similar. So if you have the other way around, so if you have something like 12 cube or 13 cube, same process, just the direction is different. So what you do is 1, 2, 4, 8. So first the powers of this 2, 1, 2, 4, 8, right? Same thing here. It was the other way around. You just had the powers of the 3 in this case, and then you multiply this with 3. So what you have is 6 and 12, right? And then you adjust the carry, and when you're adjusting the carry, try to do it from the right side only. So 8, 2 down, 1 plus 6 is 7, and then 1. So that is 12 cube. And again you have the 1, 3, 9, 27. So just triple this, so you get 9 and 27, and then you put this down, 7, 2 plus 7 is 9. Now this 2 is carried over, 2 plus 9 is 11, 1 carry, so that is 2197. So that is how you apply the process out here. For the other one, I think you can just take this off as well. For the other one, which is of the form xx cube, so these two are done anyhow. The xx cube, if you have, what you need to do is, it's actually it's very simple. The only thing is just deal with the powers of 3, that's it. Alright, so what you have is, in this case you have 3 cube, that is 27, right? And the other way around you have also 3 cube, that is 27. Now instead of going into the process directly, just think about this in this way. Suppose I have 30 plus 3 whole cube, right? So if I have 30 plus 3 whole cube, so we'll have this 3 cube, we'll have 3 into 30 into 3 square, right? Now 3 into 30 into 3 square. Now what would this be actually? This would be 3 into 3 square, that is 3 cube again, and multiplied to 3. Again the next one would be 3 into 30 square into 3 cube. Into 3. Again this ends with 2 zeros, but then again 3 into 3 square, right? So this 30 square is giving us 3 square again. So 3 square into 3 is another 27, and that is also multiplied to 3. So basically what I'm having is, I have this 3 cube, right? So I don't even have to think about it. I mean, as this 3 into 3 square is also 3 cube, so all you need to do is you just write 4 27s, that's it. Just write 4 27s and triple the middle 2. So what you have is 81 and 81. And just forget about these two and just keep adjusting the carry, that's all. So 8 plus 1 is 9, 8 plus 7 is 35, so that is the cube of 33. So again, if you have something like 22 cube, let's say, it's a little simpler. So you have 8, 8, 8, 8. Again, doesn't matter whether you have 2 square into 2 or 2 cube directly, it doesn't really make any difference. So again, you triple these, so you have 24 and 24, right? And just adjust the carry. So 8, 4 down, 2 carried, 6, 2 carried, 10648. So that is the process. Alright. About the other one, it is the same application. It is the application of a plus b whole cube only. So I'll just try to detail this. If you feel it is a little difficult, then it's fine. I mean, just try to estimate with options. That is also okay. So start with this. So 3 cube, right? So that is 3 cube. So that is 27. You have 4 cube right on this side, 64. Then from here to here, what you do is you keep on reducing 1 power of 3 and increasing 1 power of 4. So what you're doing is, you have this 3 cube, you have this 3 cube here. Then next you do is 3 square into 4. Alright. So 3 square into 4 is 36. And then you do 3 into 4 square, which is 48. Right. And then you do triple these up. Now tripling these up, I mean, all the time it won't be a very simple number, right? I mean, even in these cases, I mean, all the time you will not have 2-digit number only, you might have 3-digit numbers. So you have 48 into 3, which is nothing but 144, and then you have this 36 into 3, which is 108, and then again the same carry adjustment. So this becomes a little cumbersome at times, I agree with this, but provided you're not good with carryovers and all, I'm not recommending you this process directly. But if you are, then it is not a very difficult one. 4 down, 6 plus 144 is 150, then 0. the 15 gets carried, right? So 15 plus 108 is 123, 3 down, and then you have the 12 carried, so that is 39. So provided you're good with carries, then it is not very difficult. But again, in order to be good with carries, you have to be good with those addition and subtraction things. So if you practice that part, then this part also becomes a little easier. So try to apply this process in some questions. We'll carry on with the other topics under discussion. But squaring is a fancy technique that always works out. I've personally used it a lot of times, and the other ones, I mean, for the cubing, these three types I have used it sometimes. This does work out pretty fast. So try to apply this and practice this a bit. So thank you again, and enjoy the session.